All right, let's take some examples again then. How about find the inverse function of f of x equals 2x plus 1, which means what are we really looking for? We want to find a function that will undo what the original function does. So let's take some examples of points because we know what we can do with points. You can basically, if xy is on the graph of f of x, then yx is on the graph of f inverse x. So let's say when x is 0, 2 times 0, 0 plus 1 is 1. If I put x equals 1, 2 times 1 is 2 plus 1 is 3. X equals 2, 2 times 2, 4 plus 1 is 5. So that means that I can fill in the coordinates for f inverse by simply doing what? Right? X coordinate becomes our new y coordinate, and our original y coordinate became our x coordinate. So these are the points. So we're looking for what would be the definition of this function. How do I undo what was done to like 0? So 2 times 0 plus 1 gave me 1. So if I have 1, how do I recover my 0 back? Well, I would added 1 last, so I would have to subtract 1. So 3 minus 1, for example, will give me 2. And 2 divided by 2 will give me 1. Let's see if that works with 5. 5 minus 1 is 4. 4 divided by 2 is 2. Oh, so since the original function multiplied by a 2 and then added a 1, you always start at the end and go backwards. So last thing we did was added a 1. So we would have to subtract a 1 and divide by 2 instead of multiplying by 2. And so if you write y equals 2x plus 1, remember to find inverse functions, we have to rewrite y becomes our x and x becomes our y and solve the equation for y. So subtract 1, divide by 2. So that's our inverse function then. So this is going to be the standard process of finding inverse functions. It makes sense by what you just saw right here. So switch x and y, solve for y. That will give you your inverse function. So inverse function of x, subtract 1, divide by 2 will undo what you did right there. All right, what if you're given a function in this manner? Well, that will be easier to see. So to find inverse function, remember, if y equals f of x, then x equals f inverse of y. So all you have to do is switch the x and y coordinates. So f inverse will be 1, negative 2, 4, 0, and 6, 5. What about domain? Domain of f is negative 2, 0, 5, because those are the coordinates input. And the range would be 1, 4, 6, and then it will be the reverse for the f inverse function. So you can see that the inverse function reverses the xy coordinates. So for example, f inverse of 1 is negative 2 because f of negative 2 was 1. You understand? Let's do composite functions. F composite f inverse. When 1 goes, negative 2 comes out. Negative 2 goes into f and output is 1. And the same thing happens if you plug in negative 2. F of negative 2 is 1, and f inverse of 1 is negative 2. So note that for all one-to-one functions, for any y in the domain of f inverse, f composite f inverse y is y. For any x in the domain of f, f inverse composite f of x is equal to x. Just remember that. All right, so now let me ask you to pause the video here, take this function and find the inverse function. Start out by writing y equals f of x equals f of y, and then solve for y. And you know how to solve equations, so go ahead and do that. Don't just keep playing the video. Pause the video here, please. This is very, very important because you're going to have to do a whole bunch of problems like that. All right, so let's see what we got. So if you want to solve this equation for y, we have to get rid of the denominator. So we have x times 3y minus 1 equals 2y plus 5, multiply x out and solve for y. So carry all y terms together, everything else on the other side. What's the advantage of doing this? Can you see what to do now? How do I solve for y? Well, I can factor the y out of the left-hand side and then solve. So there's my inverse function then. It's x plus 5 over 3x minus 2. And so take a look. Inverse function is x plus 5 over 3x minus 2. All right, what about domain of f of x? That's easy to find. Domain is all real numbers here that make sense. So the only thing that will not make sense is 1/3, because 1/3 makes denominator 0. And again, domain of the function f of x is the range of f inverse. What if I want the range of this function? That's harder to see. But we just found inverse function, so I can just find domain here, which would be range here. So all real numbers except what? Go ahead and finish that off. That's right, domain of f inverse is everything but 2/3. So negative infinity to 2/3, and 2/3 to infinity would be the range of f of x. So here's one advantage of finding the inverse function. All right, you do this one. Go ahead and find the inverse function. So start by writing x equals y minus 2 cubed. Now here we can't solve for y right away. You'll have to do something before you can get to that y. In this particular case, we know that we can get rid of cubes by doing a cube root, right? So I can take a cube root of x, and so then add a 2. So it is possible sometimes that even if you have a 1-to-1 function, you cannot get to that y because there's no way to solve for the equation. And we will do an example like that shortly. All right, and then find a domain and range. Because it's cube root and cubes, all real numbers are domain and range. All right, let's do square function. Let's do x minus 3 squared. Now, remember, inverse function only occur for 1-to-1 function. If you do x minus 3 squared, that is not a 1-to-1 function unless we restrict our domain to x greater or equals 3. This will allow every output to come from a unique input. If you take all real numbers, then positive and negative number squares will give you the same numbers, which will cause problems because it will no longer be 1-to-1 function. But if you restrict the domain like this, then it will work. So let's see what we got. So we have x equals y minus 3 squared, and we are only looking at y greater than or equal to 3, which means that this is going to be, x is going to be 0 and higher. So can I take square root? Yes, and it will be positive square root, because I know that since y is bigger than 3 or 3, 0 is the smallest it can be, or anything higher. So I know square root x makes sense. So square root x plus 3 would be my inverse function. So domain here is 3 to infinity, and the range will be 0 to infinity. Why? Because that's my domain here, right?